channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start discussing about the chemistry part 2, which is your class 10th class. We had done your 9th class in the last session, where in that we discussed about the mechanism and the substitution nucleophilic biopolymer, that the reaction we have to discuss today itself. Other than that, we had done your haloalkanes react that with the casein to form the alkyl cyanide as main product, while AgCN forms isocyanide as the chief product. You have to explain that what we have discussed in the last classes. So today we continue with the same, with the mechanism and the substitution nucleophilic that is biomolar reactions as well. So before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Let's go for it. This is your unit 10. That is haloalkanes and haloarenes. So now we go for the continuation, and that what we have, and so the same, the reaction we have OH, here it is minus, plus Cl H H H, that will give HO, this H Cl, it will give so here it is HO, H H, and this is H plus Cl minus. This is the reaction here, and now we talk about, for as you have already learned in this last section, which is about of class 11th, that we discussed, where the solid wedges that represent the bond coming out from the paper, of the paper, dashed line going down the paper, and the straight line representing the bound in the plane of the paper. So this can be represented diagrammatically with the molecular structures with the same, and which is that the red dots that represent the increasing the incoming hydroxide ions, and the green dot represent the outgoing halides. In the year 1937, Edward Davis Hughes and Sir Christopher Ingold processed a mechanism for an SN2 reaction. Here that it depicts a bimolecular nucleophilic displacement, which is SN2, that is reaction. The incoming nucleophile interaction with alkyl halide, that causing the carbon halide bond to break while forming a new carbon, that is OH bond. These two here that processes that take place simultaneously in a single step and no intermediate is formed as the reason reaction that the progresses and the bond between the nucleophile and the carbon atom starts forming. The bond between carbon atom and leaving group weakens. As this happens, the configurations of carbon atom under the attack inverts in much the same way as an umbrella is turned inside out when caught in a strong wind, and while the leaving group is pushed away. This process is called inversions of configuration, and in the transition state the carbon atom is simultaneously bonded to incoming nucleophile and the outgoing leaving the incoming nucleophile and the outgoing leaving group, and such structures and that are unstable and cannot be isolated in a is because the carbon atom in the transition state is simultaneously bonded to five atoms and therefore is unstable. In the same way with the Hughes that worked under Ingold and earned a DSc degree from the University of London. Since the reaction this reactions requires the approach of nucleophile and the carbon bearing the leaving group where the presence of the bulky substitute or on or near the carbon atom that have a dramatic inhibiting effect. And on a simple alkyl halide, the methyl halide reacts most rapidly in SN2 reaction because there are only three small hydrogens atom, and tertiary halide the least reactive because bulky group hunger that is hinder the approximate that approaches to the nucleophiles, and thus the order of the reactivity that has been followed, the primary halide is greater than secondary halide and the secondary halide is greater than the tertiary halide, so that I can write it down here itself for you, which is primary halide is greater than secondary halide is greater than tertiary halide. Okay, so which is your methyl, discussing about methyl here, ethyl 1 degree, and then isopropyl 2 degree, and at third butyl which is 3rd degree. So let's go for it. So first is discuss about methyl. This is methyl 30. Another is this is H ethyl 1 degree. Another is no. H and H. Isopropyl 2 degree. This is X, carbon, hydrogen, carbon, hydrogen, then carbon, hydrogen. So this is your tert butyl 3. So here the some effects of SN2 reaction, the relative rate of SN2 reaction is to be given in the parenthesis that we discussed. Now we discuss about the second one, which is the substitution, a nucleophilic unimolecular SN1 reaction. So let's go for the same. So the second part we have substitution, nucleophilic, unimolecular SN1. This is the reaction. Here SN1 reactions are generally carried out in a polar proctic solvent, water, alcohol, acetic acid, etc. The reaction between the tert butyl bromide and hydroxide ion yield tert butyl alcohol and follows the first order kinetics, and that is your the rate of reaction. Here in terms of it, the rate of reaction depends upon the concentrations of only one reactant, which is tert butyl bromide. So let's go for the reaction here first, and the reaction is CH3 whole thrice CBr plus OH will give CH3 whole thrice COH plus Br minus 2 methyl, the product will be propan 2 all. Here it is your 2 bromo 2 methyl propane. So 2 bromo 2 methyl propane से 2 methyl propan 2 all बना है, and it occurs in the two steps. In step 1, the polarized carbon and bromine bond under taking the slow cleavage to provide a carbocation and the bromide ion, and the carbocation thus formed is that attacked by the nucleophile in to complete the substitution reaction. So that what we have here. So let's go for the reaction here, so that it will be helpful for you to understand, and let's figure it out as well. Then we'll discuss about the SN2 reactions and the SN1 reaction, how it will increase and decrease in the same pattern. That what we'll discuss here. So let's go for it. The reaction we have CH3 whole thrice CBr. Okay, step 1, CH3 CH3 plus Br minus Now we have CH3, CH3, CH3 plus OH minus. Step 2 will give CH3 whole thrice COH. And so here it is. Step 1 is the slowest and the reversible. It involves the carbon bromine bond breaking, for which the energy is obtained through solvations of halide ion with a proton and a protic solvent. Since the rate of the reaction depends upon the slowest step, and the rate of the reaction depends only on concentrations of alkyl halide and not the concentrations of hydroxide ion. Further, the greater the stability of the carbocation, greater will be its ease of in the case of the formation from alkyl halide, and the faster will be the rate of the reaction. In the case of alkyl halide, the 3-degree alkyl halide undergoes SN1 reaction very fast because of the high stability of 3-degree carbocation. We can sum up the order of reactivity of alkyl halide towards SN1 and SN2 reaction that has been as follows. Let's go for it. This is for SN2 reaction. So here tertiary halide, secondary halide, primary halide, and CH3X. So for that, this is for SN1 reaction. So that here it is for the same reaction, that is allylic and benzylic halide, that shows the high reactivity towards the SN1 reaction, and the carbocation thus formed get stabilized through resonance, and that will be discussed in the last units we had discussed about it. Let's go for the reaction that we have. So here we go. So that all we discuss in the next coming class. So here we're going to end up with. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. So this has been the last one. CH2 bond CH, double bond CH2. So this is here, and the reaction it will give CH2 it will give so this has been coming here. This is come here. CH2 plus. So here for a given alkyl halide here, that is for the given alkyl halide, that alkyl group, the reactivity of halide Rx that follows the same order in both the mechanism, where it will be Ri is greater than RBr, greater than RCl, greater RF. This is the reaction. So iodine, then bromine, chlorine, and then fluorine. It will take place in the same way. Now we have a questions here, that is I will give you as a homework. If you are able to, you can solve it out, and if you are not able to, I will be providing you the solution as well, so no worry about that. But it is important, so that's the reason I had given you. So there are many two questions that you have to deal with the same. So for the first part, we'll discuss about in the following parts of the halogens compound which would undergo SN2 reactions faster, and that is your CH2Cl with that is of having a figure with a chlorine. And another the question which we'll discuss, you have to predict the order of the reactivity, and on the same way that following the compound of SN2 and SN1 reaction which is comes under in it, and that you have to solve accordingly. Let's go for the end up here. We'll discuss the rest in the next coming class. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you.